All right, welcome everybody. Welcome. So a couple things I want to mention here. So there's a possibility that Monday's class meeting time could be a little disrupted. So here's the situation: is that there is so they're still repairing and replacing the power line poles in my neighborhood from the Thomas fire. My neighborhood was one of the ones we lost. I think we lost around 220 homes or something like that in the fire. So a lot of homes burned up in the neighborhood. They're still replacing power poles. 4 years later? They were supposed to replace one a couple weeks ago, but that was the day it rained, and so they rescheduled, and they've rescheduled it for Monday. So it is entirely possible that I won't have power at my house on Monday. So, but it's possible they will, because I would say half the time that we have these scheduled, they end up rescheduling them for one reason or another. So it's entirely possible that class is going to go on as normal. But it's also possible that there'll be a disruption. So in that case, what I'm going to try to do is go to my office and have it will be a much more limited class meeting, but I will try to have the Zoom meeting from my office. So those of you who normally tune into the YouTube stream, if on Monday there is no YouTube stream available, then in all likelihood that means that they did in fact cut the power to my neighborhood to replace that pole. But it's also equally likely that they will reschedule and I will have power as normal on Monday. So who knows? So, but I will try to have the Zoom meeting open, because I don't have equipment in my office for proper streaming, but I can just do a Zoom meeting. So I'll be limited as far as what I can show you, but I can talk about stuff and I can do a few things on the whiteboard screen here and stuff like that. So just kind of be aware. If you're one who likes to watch on the YouTube stream, and you come Monday and it's not there, hop over to the Zoom and see if I'm doing something in Zoom, and also give me a few extra minutes, because since I'll be in sort of a weird environment that I'm not used to, maybe there'll be some complications. Maybe there'll be some things where it takes me a few extra minutes to get things up and running. The Wi-Fi in my office is notoriously bad, and then they always say they fix it and say your Wi-Fi should be good now, and then it's not. So who knows if it's going to work well or not. But that's what I'm going to try to do. So just so you have a heads up and you know what's happening Monday, there may not be a YouTube stream. I'm really hoping I can get the Wi-Fi in my office to work, or I may have to go sit in a classroom. Most of the classrooms are empty right now, and try to give my class from there. But we'll figure it out, okay? But in case something goes weird, you won't be like, what's going on? Where's my teacher? You'll know, oh, this is what's happening, okay? Okay, are there any questions? So we're moving along. We've got, the 2 chapters left to do, I think. Let's see, where are we? Trying to remember. Here we are in I know we're talking about roots right now, but I'm trying to remember how much we have left. So we've got we're working on chapter 7, and then we got 8 and 9 after that. So we got to get through those 2. Okay, yeah, that sounds good. Not too much more in chapter 7 to talk about. So next week we'll start hitting up chapter 8. Chapter 8 is nice because, well, it depends how you view it. Chapter 8 really just has a few things. Like this chapter is just chock full of stuff you got to remember. All these different types of problems, and you got to remember to do them differently. They're overall, each individual thing that you learn in this chapter is fairly simple by itself, and that doesn't mean easy. Simple just means it's not complex, right? It's not like with a lot of moving pieces. It's just, this is how you add roots. This is how you multiply them, all those different kinds of things. So this chapter has lots of little things. The next chapter has a handful of big things. So completing the squares, kind of a big thing. Quadratic formulas, kind of a big thing, right? In fact, those are like the 2 big things from the next chapter. But there's a couple other details. But there's like a handful of really big topics versus this chapter where it's many, many little tiny details that we need to look at. So, let me show you a couple things. And by all means, if you have questions, specific things you want me to talk about, let me know. I'm just sort of picking and choosing which things to talk about, but it's also helpful if students request things, because then I know for sure that at least somebody needed to see that. So we talked about multiplying radicals last time, and it's pretty straightforward. You just multiply the things together and then simplify, as long as we're dealing with things that simplify to real numbers. But what about adding and subtracting roots? That gets a little bit more complicated. So what if I have something like the square root of 5? In fact, let's be brave. Let's make it a little harder. 2 times the square root of 5 plus 3 times the square root of 7. Whoops, I'm missing a backslash. There we go. So imagine something like this. Now, how would you go about adding together 2 times the square root of 5 plus 3 times the square root of 7? Well, remember, when we're adding and subtracting things, what we're really doing is just counting, right? If I have 2 apples in my left hand and 3 apples in my right hand, I have 5 apples altogether. We did addition, but that addition was just giving us a count. Okay. Essentially, that's what we're going to do here, is say, well, I have 2 square roots of 5 and I have 3 square roots of 7. How am I going to add those together, right? It's the old apple and orange type of thing. Well, I've got 2 apples and I've got 3 oranges. I don't really have 5 of anything. You could argue 5 fruit, but that's not really helpful because that actually gives us less information than we started with. So can't simplify these, right? So basically, just think back to like terms. Remember when we were talking about like terms before? And we would talk about, oops, keep hitting all the wrong buttons here. 2x plus 3y. If we had 2x plus 3y, we can't add those together. Those are 2 different types of things. Those are different. They're not like terms. But if we have something like 2x plus 3x, we can add that together and say, well, I have a total of 5 x's. So what we can do with square roots is if I have something like 2 times the square root of 5 plus 3 times the square root of 5, then how many square roots of 5 do I have? Well, in that case, I would have 5 square roots of 5. Right? So just keep that same concept in your head of like terms when you're adding things together. And if you have things that are like terms, add them together. It's, assuming that's the operation that you want to do. If you don't have them, then you can't do it, right? So there is a problem that I want to go over here. Here we go, like this. Okay, so now with that said, I'm about to do something that's going to look like I'm doing the opposite of what I just said I was going to do, right? You're going to go, wait, you just said that we can't do that, but I'm going to show you why we can in special circumstances. So let's say I've got the problem, square root of 75 plus the square root of 27. Okay, so it's very reasonable if you're sitting there and going, well, you just spent all that time. You just spent like 5 minutes explaining to us why you can't add these together. Well, we can add them together. The work that I was talking about up here is on fully simplified radicals. These radicals right here, these roots, are not fully simplified. So we have to simplify them and see if they are like terms, right? Which I'll do in just a second. Once we see if they're actually like terms or not, then we can make the decision if we can add things together or not. So remember how we're going to simplify something like this is we're going to break up our square roots into pieces that are perfectly simplifiable and pieces that are the leftovers, the remaining pieces. So we can break up square root of 75 into the square root of 25 times the square root of 3, right? Now, let's see. Let's let it catch up here. So why did I break the square root of 75 into square root of 25 and square root of 3? I took the biggest perfect square that I could, 25. 25 is the largest perfect square that divides 75, and I broke it off out to the front because I know I can simplify that piece perfectly. The square root of 25 is 5, right? And then we have this leftover piece of square root of 3. Now let's do that with the square root of 27. So what am I going to do there? Well, I'm going to break that up into two square roots, one piece that is a perfect square and one piece that is the leftovers. Well, the biggest perfect square that divides 27 is 9, giving us a leftover of 3. Some of you might start to see where this is going and the little lights turning on going, oh, I see how to do this, right? Well, let's just go through and simplify so everyone can see. Square root of 25 is 5, and then we're left with the square root of 3 plus square root of 9 is 3, and then we've got that leftover square root of 3. So lo and behold, even though we started the problem and it looked like we had unlike terms, once we simplify, sure enough, we do have like terms, right? So this would be like having a simplified fraction and an unsimplified fraction and looking at the denominators and saying, oh, I can't add those together. But then when you simplify the second fraction, you go, oh, they have the same denominator. I can add those together. So here, this will simplify too. If I have 5 square roots of 3 and I have 3 more square roots of 3, I have 8 square roots of 3. Okay, so see how that works? So the addition and subtraction sometimes is tricky. So you have to simplify the terms in your problem. And once you have them simplified, then you look for like terms. In this problem, we ended up with some like terms. In other problems, you will not end up with like terms. Okay, so you just won't be able to do those then. Okay. All right. Let's see. Where was there was something I was going to show you. Yeah. So something like this. So this goes back to, I'm going to have to keep moving this. This goes back to what we were talking about last time. You look at this and you're like, man, that's confusing. The 4th root of the 3rd root of j, and I'm supposed to write this as a single radical using the smallest possible root? I'm confused. What am I supposed to do there? Well, the answer is what you're going to do is use those fractional exponents. We call them rational exponents. Rational means it's ratio. Fractional exponents is what's going to get us through this. So remember that conversion. We looked at it last time for converting those problems like that. So let's see. The 4th root of the 3rd root of j. Okay, let me get that there. So we've got the 4th root of the 3rd root of j. Let's see if I did that right. That's weird. Oh, that's weird that it won't format correctly. Why is it doing that? Let's do this. Give me a second. For some reason, this isn't formatting right. Okay, so we've got the 4th root of j. So what if we want to make this the square root of j? Okay, weird. It's doing some type of error here. Here's the key that we want to recognize is that, remember, the root that you're taking ends up being the denominator in your rational exponent, and the power something is being raised to is the numerator. So really, this outer part we can think of as being something raised to the 1/4 power. I know it's going to let me do that. So let's change this to be the cube root. Okay, so we've taken the outer part and changed it to the power of 1/4. So that square root, or that, yeah, well, the fourth root becomes the 1/4 power, using that same formula as we used last time to convert from fractional exponents back and forth. Okay, so if we take the 1/4 power of this, well, the third root of j is really j to the 1/3, right? So this becomes j to the 1/3. So this would convert to j to the 1/3 to the 1/4. Okay, now you just fall back on your rules of exponents. What are we supposed to do there? Our rule of exponent for this situation is that we multiply. So if I multiply 1/3 times 1/4, I get 1/12. So they don't want me to write it as a rational exponent, though. They want me to write it as a single radical using the smallest possible root. So this should be the 12th root of j. Okay, so see, they did the same thing I did. They worked from the inside out. They converted the inside first to j to the 1/3. That's fine. It doesn't really matter. Both me and the computer here ended up with this, j to the 1/3 to the 1/4. And then you use your rule of exponent that says you multiply those exponents. You get j to the 1/12. And then, let's see, it's cutting off the bottom here. And then you get the 12th root of j. So it's really just a little bit of practice with that rational exponent going back and forth to understand how it works. Let's look at another one. Oh, yeah, same idea. So you get it. Let's try this one. Use the properties of exponents to determine the value of a for the equation x squared times the 4th root of x to the 5th equals x to the a. Okay, so let's think about this. We've got this is x squared, and how are we going to convert this part? Well, according to our formula, this is going to become x to the 4/5, right? That's how we convert this to a rational exponent, x to the 4/5. So really, in that case, we've got x squared times x to the 4/5 well, 2 is really 2 over 1. So if we multiply across, we're going to get 8/5. So this is the same as x to the what did I say, 8/5? So it looks like that's what we're supposed to put in over here. They want to know what a is. So the answer is 8/5. Okay, well, hold on. Use the properties of exponents to determine the value of a for the equation. Okay, what have I done here? X squared. Oh, sorry. I totally wasn't reading this right. It's x to the 5/4. Sorry, I got my two numbers mixed up. Sorry if that misled anyone. Remember, the power is your numerator. The index is your denominator. Well, I wasn't looking closely enough. So this should be 5. Sorry if I confused anybody there. This should be 5/5 fourths, which would make our answer which means our answer then should be 10 fourths, which would reduce to what? 5 halves? Yeah, 5 halves. So our answer here should be 5 divided by 2. Uh-oh, what did I do? 5 fourths times it would give us 10 fourths. Oh, all right. Sorry. Let's try another one. I did a couple things wrong there. Just ignore that. Let's try another one so I can walk you through it. Let's just start fresh here. Okay, so we've got the 5th root of x squared. So this part on top is going to become x to the 2/5. This part on bottom will become x to the 2/5 because we're going to multiply these. So does everyone see how this would become x to the 2/5 on top? The power is your numerator. The index is your denominator. So it should be x to the 2/5 over x to the 2/5. When we cancel that, this should be really x to the 0, right? Yeah. So 2/5 minus 2/5 is 0. So we get x to the 0. So that's how you do that. So it's just, there's a lot of problems that are really, really hard and confusing and scary. But as soon as you convert everything to those fractional exponents, it's like it just sort of works itself out, right? Like, but you can see it's easy to make mistakes. I just screwed up that one a minute ago where I had like, what, 2 mistakes on the same problem. That's not great. Let me double check this one. These get a little complicated, but you just work through them. Don't get overwhelmed. You know, make sure you're writing it in the form that they want you to, and then just work your way through the problem. You'll be just fine with it. Okay. Okay, we looked at those. Oh yeah, adding radicals with x. So we did that. Let's do another one of these. Okay. So 10 times the square root of 45x to the 4th. These ones I find people need a little more practice with. So 10 times the square root of 45x to the 4th. Is that what it was? Okay, minus 9x. (45x squared). Okay, so that looks different. So we can't combine these yet, right? They're close. They look like they're similar, but they're really not. 45x to the 4th and 45x squared are not really the same thing. So what are we going to do? We're going to simplify those roots as much as we can, and maybe our differences between these two radicals is going to work itself out, or are going to work themselves out possibly. So let's see what we can come up with. So we've got 10. Okay, I want to break down 45. It seems like I would break it down as 9 times 5. I think that's the biggest perfect square that goes in there. So square root of 9. And in fact, I'm going to go ahead and throw the x to the 4th in here because that's can be simplified. And then I've got the square root of, there's really the only leftover is 5, right? The 9 times 5 to get 45. Okay, then we've got minus. We already have a 9x out front. And then we've got what? We've got our square root that is going to be the simplifiable part. Well, that's, again, going to be 9, but this time x squared times the square root of 5. Okay, so I've just broken the pieces down there so that they're ready to be simplified. All right, so let's write our next line. All right, well, we've got our 10. Now, 9x to the 4th, what do we square? What do we square to get 9? 3. What do we square to get x to the fourth? X squared. So this should become 3x squared times the square root of 5. There's nothing we can do with the square root of 5. It's just left as the square root of 5, right? So minus, now we have our 9x. The square root of 9x squared is going to be 3x, right? And then we're left with that square root of 5. Now we have some multiplications to do here. So let's see. This is going to be 30x squared square root of 5 and then minus, so then we have what? 27x squared square root of 5. And now it looks like we can combine these things together. If I didn't make some kind of big mistake, this should leave us with 3x squared square root of 5. 3x squared square root of 5. See, hopefully I didn't make a mistake in that one. 3x squared square root of 5. 3x squared square root of 5. Whew. Okay, got it. All right, so you can see the same basic idea. That you can even see it looks like what I did, where they broke it down into the perfect square piece and then the leftover piece. Right? So same idea. Right. Okay. So I think we're good with those. People usually pick those up. We've looked at multiplication. We've looked at looks like there's some binomial problems here. Guess how this one works? You're just going to use FOIL. So the same pattern that you use to multiply polynomials, you'll use for these. So how would you do this? You'd go first, outer, inner, last. Okay. Just go through and do those operations and then simplify them. So there's nothing difficult, or I mean, it might be difficult, but there's nothing like tricky about that. Just a couple things you got to look out for. All right, let's look at solving equations, radical equations. What are you going to do? Well, there's some basic steps you're going to follow for every radical equation. Now, some of these, like the one we're looking at right now, not too bad. Some of them can get a little bit where it's not so fun to go through and work through these problems. So let's take a look at it. So we have x plus 8 plus 3, square root of x plus 8 plus 3 equals 5. Okay. So we've got square root of x plus 8 plus 3 equals 5. Okay, now I'm having a computer format all this for me, so it's pretty easy to read. One thing I see in this chapter is students with bad handwriting that are sloppy with their work end up messing themselves up. For instance, I'll see students start with something like this, x plus 8, and then when they write it on the next line, this line kind of carelessly comes out this far, and then they're not paying attention and they think the 3 goes on the inside of the root. Here, when it's being formatted by a computer program that was designed to format math, we don't have those issues. But when you're drawing these by hand, it's not always as clear cut. So just make sure you're paying attention to this sign and not being too sloppy with how you're writing it. You're writing it in a way that you can definitely tell what's inside the square root and what is not inside the square root. Okay, so step 1 is to isolate one square root. So what does that mean? What do I mean isolate a square root? That means it's just like when you isolate the variable. You're going to get that variable all by itself. Here you're going to get one of the square roots all by itself, right? So what we're going to do then is get the left so that the square root is the only thing on the left. So what am I going to do? I'm going to get rid of this plus 3. How do I get rid of a plus 3? I'm going to subtract 3. Okay? So when I go here, I'm going to go square root of x plus 8 equals, okay, 5 minus 3 is 2. Okay, so see how we've isolated that square root? It's all by itself on one side of the equal sign. Great, that's step number 1 done. Okay, step number 2, you want to undo the root. So most of the problems you do are going to be square roots. So how do you undo a square root? You square it. But if you happen to be doing a problem that has a cube root, the way you're going to undo the cube root is to cube it. Okay, but so just basically you raise it to the appropriate power. Most of the time that's going to be squaring because you're dealing with the square root. So in this case, I'm going to square both sides. Now this is one that seems easy, and for a problem like this, it is easy. But as you'll see, we get into some where it gets gross. Like you go, I got to square that. And then if you're not paying attention, you're going to square it wrong. And then, of course, the whole problem is a mess after that. Okay, so if I square root of 8, x plus square root of 8, I get x plus 8, right? That's what happens when you square a square root. You just get the thing inside. Now if I square 2, I get 4. So this whole thing becomes x plus 8 equals 4. Now we have to be careful because it's the same thing that happens when we do, let's see, we already did rational, getting my classes mixed up. We already did rational expressions, right? Yep, that was last chapter. Remember, in rational expressions, you have to check your work. It's not just that we're saying, it's a pretty good idea if you check your work. We're saying it's part of the process because you can get answers that are extraneous and not actually solutions, even if you did everything right. Same thing here. It's because of that squaring process for this problem. That squaring process can introduce extraneous solutions, and you have to just double check that you have to double check that your solutions work in the original problem. Okay, so we're going to square both sides to get this. This is pretty easy to solve, so we'll get that x equals -4. Okay, well, let's check it. Let's check it by plugging it in. So I guess technically there was a step here that I didn't write. Solve, right? You solve the equation. And then our last step is to check. So can we check that? Let's see. If I plug -4 in here, I get -4 plus 8, which is 4. Square root of 4 is 2. 2 plus 3 equals 5. Yeah, that one works. So let's go put that in. So the answer is -4. There we go. We got our answer. And you can see they did the same thing. Squaring both sides, all that kind of. Isolate the variable or the square root, square both sides, solve the equation, check your work, right? All good to go. All right. Now notice there's levels. They ramp up. That was the easiest version. Let's see what a level 2 looks like. Okay. Here's where it gets a little more complicated, and you have to be careful with squaring both sides. Right? This is that thing that we try to break students from doing, and they learn it the right way, and then in the next math class they take, they're doing it wrong again. That is, when I square a sum, it is not the sum of squares. You don't get to just square the individual pieces. I'll show you what I mean by that. So let's take a look. So we've got, what was it, the square root of, was it 61 minus 10x? 61 minus 10x equals x minus 7. So here's our new problem. 61 minus 10x equals x minus 7. The square root's already isolated for us. That's going to happen a fair amount of the time. I don't know, half the time, maybe a little more. You're already going to have your square root isolated. So that's step number 1 already completed for you. You got great news. Okay, but now we're going to square both sides. Squaring the square root is easy. You just get what's inside. 61 minus 10x. Okay. Now we got to square the right side. But think about that. What does that mean to square both sides? Is it x squared minus 49? No. You can't just square the x and then square the 7 and go, I squared it. Because remember, here's how you're supposed to think about it. Is that it's the quantity x minus 7 squared. It doesn't work if you just take x squared and you square the 7. It doesn't work. You don't get the same thing. We have to do this. So basically, remember, you're going to FOIL this. You're going to write it out, x minus 7 times x minus 7. You're going to FOIL it, and then you're going to see what you have left. So 61 minus 10x equals, squaring x minus 7, I get x squared minus 14x plus 49. Right? If you don't believe me, just FOIL it. But notice how what I don't get is x squared minus 49 or even x squared plus 49. There's that 14x in there, the negative 14x, which makes it a little bit more complicated. But here's the good news. We don't have a problem with roots in it anymore. We have a polynomial. In fact, we have a quadratic polynomial, and we learned how to solve those 2 chapters ago, right? So let's get to doing that. So let's see. Let's get everything on the right. So I've got x squared. All right. If I'm gonna add 10x to both sides, so that gives me minus 4x. And I'm going to subtract 61, which is going to give me what? 12? Negative 12? Seems right. Okay, so I'm looking to solve this by taking, I'm just going to throw the 0 on the right side now just because I kind of like it being over there. So this is probably going to be what? X minus 6, x plus 2. Let's take a look. If I do that, I'm going to get what? I get x squared plus 2x minus 6x minus 12. Yep, that's right. So that means that our answers are either 6 or negative 2. And if we plug those in up here, for instance, let's plug in 6. 61 minus 60 is 1. The square root of 1 is 1. Is that equal to 6? Here, let's finish this out because I don't want to lose anybody because this is kind of an important issue. So x minus 6 equals 0, which implies that x equals 6. The other one we get is that x plus 2 equals 0. So x equals negative 2. But now we have to check these, right? And here I'll prove to you that you have to check these because I think this one is one of those where we get an extraneous solution. Let's plug in the 6. So that's 61 minus 60. Square root of 1 is 1. So we have 1 on the left side, right? What about 6 minus 7? Oh, that's negative 1. So this simplifies to 1 equals negative 1. No, that's an extraneous solution. This one's no good. So extraneous solution. In other words, it's not a solution. It's like a decoy. It's a fake. Okay, we just got duped with some kind of like fake thing that we thought was a solution, but it's not. But we didn't get tricked, right? Maybe for a second we were hopeful. Oh, maybe we got a solution here, but we sort of kept our eyes out and paid attention and said, nope, not actually a solution. What about negative 2? So if I plug negative 2 in here, I get 61 plus 20, which is 81. Square root of 81 is 9. Is 9 equal to negative 2 minus 7? So 9. Negative 2 minus 7 would not be. So are they both extraneous? Solve for all possible values of x. Did I mess something up? Positive 6, negative 2. Negative 2 minus 7 would be negative 9. If I plug that in there, I get 9. I think they're both extraneous solutions. I forget. What do they have us put if there's no solution? Did you just type no solution? It's been a little while. I'm probably messing up again. Oh, yeah. The answer is, just leaving it blank. Okay. No, so I was right. They're both extraneous solutions. Yeah, and that's actually, so in chat, I'm saying someone put 0. That's actually really good. I'm glad that was brought up because a lot of students do that where they'll put a 0, but 0 is an actual number, right? 0 can be a solution. So 0 doesn't represent no solution. You don't want to do that. It'll mark you wrong. So what I was supposed to do was just leave it blank. I forgot that that's how this software works because different math softwares want you to do different stuff in this situation, and that's one of them. Okay, so I'm glad that point was brought up. All right, let's look at level 3. Ooh, 2 square roots. That's kind of a mess, huh? And then what are these ones? Still just 2 square roots. So what are you supposed to do if there's 2 square roots? Well, the problems admittedly get more tedious. They get a little bit harder. But the directions are the same. You're going to follow the same procedure. Excuse me. The hiccups. You follow the same procedure. You isolate a square root. We've got that. We've got one square root isolated. Great. Step 1's already done. Now we square both sides. Now that might panic you a little bit, and you go back to that part where you're like, ooh, do I just get to square each piece? When I square this, does it become x? And when I square this, it becomes 1? No, you don't get to just do that. You have to square this. So how are you going to do it? Just like the last problem, you're going to FOIL it, right? So let's take a look at this. In fact, I'm going to just flip the problem left and right because it's just the way it's going to work out. So let's do it this way. So I've got the square root of what was it? X plus 2 equals the square root of x plus 1. Is that what it was? Square root of x plus 1, square root of x plus 2. Okay, so we have this, right? I've just written it on the opposite sides because I find it a little easier to write it this way. Okay, so what am I going to do? We square both sides. Left side, easy. When you square a square root, you just get what's inside, x plus 2 equals. Now's the part where it's a little weird because how are we going to think about the right side? We're going to think about it like this, that it's this quantity squared right? We're thinking about it like this, which means we're going to FOIL it, right? We're just going to go through and perform a FOIL. So when I do that, I'll go ahead and write it out here. You see what I'm saying? The left side's easy, but now I got to FOIL this. Now don't panic. Some students they get intimidated by this, but you know how to do this, okay? You know FOIL and you know how to multiply roots. So square root of x times square root of x is x. I do the outer, I get square root of x times 1, so I get plus square root of x. The inner is 1 times square root of x, so I get plus square root of x. The last is 1 times 1, so plus 1. So we get x plus 2 equals, let's see if I can finish this. Okay, now notice over here, what's square root of x plus square root of x? Well, that's 1 square root of x plus 1 square root of x, giving us, we have x plus 2 square root of x, and then I have a plus 1. Oh, it looks like they may have set this one up to simplify rather nicely. Sometimes they can get a little messy here, but this one's going to simplify nicely. So you go, okay, well, yeah, in fact, let's go ahead and do that simplification. So assuming I didn't make any mistakes here, the x's should cancel on both sides. So subtract an x from both sides, and then subtract a 1 from both sides, and I get 1 equals x plus 2 times the square root of x. Okay, that's what it should be. Those x's cancel. 2 minus 1 is 1. Okay, so now you go, okay, but now what do I do with this? Well, you just repeat the whole process. Remember, so you just go back to step 1 and you repeat it. You're usually going to have to do that, not every time, but usually however many times there's a square root in your problem, that's how many times you're going to have to repeat the process for solving the problem. So notice how it's better though, right? If you look at our equation, we have 1 square root. Well, our original equation had 2 square roots. So we've improved things. We've gone from 2 square roots to 1 square root. So now you're just going to go through and simplify this. So what do? You isolate the root, and you go, okay, subtract x. So that's going to be 1 minus x equals 2 times the square root of x. And then you have some choices here. You could divide both sides by 2. That's going to give you a fraction on the left. Or remember, we can actually square this directly. We just have to square each piece here because it's multiplication. That's different than up here where I kept telling you can't just square the square root of x and square the 1. That's because there was a plus in between them. But we have a rule for powers that says if we have a times b and we want to square it, then you can square each piece. So it's the difference between a multiplicative operation and an addition operation. So, but notice on the left, I'm now, and I'm not going to have time to work through this, but notice on the left, I'm now squaring 1 minus x. That does not become 1 minus x squared. You have to FOIL the left side. You have to go through that whole process, right? So these problems admittedly get tedious, right? So let me show you. Oops, that's not what I wanted to do. I want to, oh, good, same one. Let's see the solution, just so I can show you what happened. So this first part will look the same. They squared both sides. We got it down to 2 times. Oh, did I not simplify that right? Oh, I didn't get rid of this x when I did it. So this is simpler then. So becomes this. So you get to your 1 equals 2 times the square root of x. Divide by 2, square both sides. You get your answer, right? 1/4. Okay, so even though there's 2 square roots, it's not really that much harder. You just have to go through the process 2 times in order to get rid of it. And then they have these last ones that are a little bit scary. Oh, maybe that was level 4. Same thing. You have 2 square roots. Just go through the process twice to eliminate them. Okay, so that should wrap up roots. Next time I see you, we'll talk about the next chapter, which again, it's less topics, but they're deeper topics, sort of big chunks rather than all these little tiny million details, which I know can be a little confusing to keep track of a bunch of little things, okay? So anyone who wants to talk to me, feel free to stick around in Zoom. Talk to me about whatever you want. Otherwise, I'm shutting down the YouTube stream. Have a good weekend. Remember, Monday may be weird. Be a little bit flexible with me. It may just be on Zoom. I may be a few minutes late. I'll do what I can to make sure we have at least a Zoom meeting on Monday, okay? All right. Thanks, everybody. We'll see you later.